Today's topic 2.2, defining the derivative of a function and using derivative notation. Topic 2.3, estimating derivatives of a function at a point. And finally, topic 2.4, connecting differentiability and continuity, determining when derivatives do and do not exist. So let's start off with the intro. Recall that from topic 2.1, f prime of c is equal to the limit as x approaches c of f of x minus f of c over x minus c. This limits which calculates the derivative of the function f where x is equal to z. C can be expressed a little differently. Now, what if we wanted a general derivative that can be computed for any value of x and not just at c? So, activity, consider the limit as x approaches c of f of x minus f of c over x minus c. We're going to let x be equal to c plus h. So, what I want you guys to do is substitute for x, c plus h, and then simplify. So when we do that, we're going to get the limit as x approaches c of f of c plus h, right? We're doing the simplification now of f of c minus c plus h minus c. And then again, you guys simplify one more time. The limit as x approaches c of f of c plus h minus f of c all over h. So this pretty much is the alternate form of the derivative. And then again, another way to think of the derivative of the function f when x is equal to c is, if we have f prime of c is equal to the limit as h approaches c, the limit as h approaches 0 of f of c plus h minus f of c all over h. So this is pretty much what's really powerful about this is that if we don't change the value c, right, but we use the variable x, we can pretty much have an expression that works for any point at any time. So definition, the derivative of function f prime, the derivative function f prime of a function f is f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, sometimes you guys will see instead of h, you might see delta x. So remember, delta x is pretty much the same thing, all right? It's a single value. It's not delta times x. Delta x is a single value. And again, what do you think would be the meaning of delta x? And if you guys recall from previous courses, delta x is the change in x, right? Delta means change, and then in this case is the change in x. So note that the word derivative is a noun. Often directions may ask you to find the derivative of a function as differentiate the function. So here, differentiate is a verb. So again, be careful, differentiate, find the derivative are pretty much the same thing. So we want to, example one, differentiate f of x equals the square root of x and determine the domain of f prime of x. So again, we're going to use a definition, and the definition is the limit as h approaches 0 of f of x minus, not f of x, but f of x plus h minus f of x over h. So we substitute. We're looking now at the limits as h approaches 0. F of x happens to be the square root of x, so we're going to do the square root of x plus h minus the square root of x all over h. And then to simplify this, so we have to multiply by its conjugates of the numerator. So it's going to be the square root of x plus h plus the square root of x, and then over the same thing, right? You're multiplying by 1, so that shouldn't change pretty much what you have. So we simplify one more step, all right? On top, you're going to have a difference of squares. So the limit as h approaches 0. In this case, so multiply the top, square root of x plus h times square root of x plus h gives you just x plus h. And then square root of x times negative square root of x is negative x divided by h times the square root of x plus h plus the square root of x. Now, if we continue to simplify here, we're going to find that on top you just have an h left over. And then your denominator is going to be pretty much the same thing, h times x plus the square root of x plus h plus the square root of x. If you guys take this further, these two will divide out, and you still have the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. If you do direct substitution, you'll see that you have 1 over the square root of x plus the square root of x. And that gives you guys 1 over 2 root x. So that would be our f prime of x. So the derivative for any point of the square root of x function. So example 2, identifying the parts of the definition of a derivative. The limits below represents f prime of c for a function, f and number c. Find f and c. So we're going to look at the first one right there. So here, if you guys are looking at it, right, inside, that should be considered our c value. So c equals 3. And then for f of x, so pretty much you guys can identify, right? If this is going to be c plus h in here, this is our function, and that's f of x equals the square root of x. So again, the next thing is for you to identify the points. What is c, right? What is the x value where this is happening? And in this case, if you notice, we have it in here, right? It's next to the delta x. So usually look for the h or the delta x, and that's tell you the number next to it is going to be almost every single time the c value. So in this case, -3, f of x would be what? What do you guys think? So here, if you notice, this is pretty much the highlighted part is what was substituted in. So that would be my like c plus h, or in this case, c plus delta x, right? So here you have 2 and then x cubed. So 2 plus x to the third. And then example C right there. So again, look for the c value. So what do you guys think the c value is going to be here? So in this case, the c value is x, right? Because that's pretty much what's next to the delta x. And then your f of x would be what? So if you notice, you have, if you cover this up, if you cover that up, if you cover that up, or if you look at this right here, that tells us that f of x equals x cubed minus 5x squared plus 4x minus 7. Now here, the nice thing about it, it's already inside of parentheses, so it's easier to identify.